Okay, in this third mini lecture working with this set of data, we conduct another two-group difference of means test, and we'll work with this set of data right here. Now, if you'll recall in the previous mini lecture, we worked with this data, and we got contrary results when we actually ran the two-sample difference of means test, given that men drank in our sample of 10 men and 10 women, given that men only drank, about, let's say, 50% less carbonated beverages per week than women, 94 ounces per week here, versus 153 ounces per week for women. We expected to get a small p-value and reject the null hypothesis, but we did not. I explained that the reason why we failed to reject the null hypothesis was primarily because our sample size was so small. Only 10 men, only 10 women. When you couple that with a fairly large standard deviation, particularly for the women, so the combination of small sample size and a large standard deviation causes us to have a very large margin of error, so that the lower bound and upper bound of our confidence interval is quite large. So we can't just manually adjust the standard error. I'm sorry, the standard deviation. I mean, the standard deviation is a calculated value. Whatever it is, it is. But we could collect more data. We could, rather than having 10 men and 10 women, we could go get data from more men and go get more data from additional women. So that's what I did here. Now, instead of actually getting more data, I just copied twice over the data from our first two sample difference of means test, so that here, rather than having 10 men and 10 women in this test, we actually have, as you'll see down here, we have 30 men and 30 women. Notice that our point estimate for men remains at 94. Our point estimate for women remains at 153. Our null hypothesis is that the average amount of carbonated beverage drunk by men per week is the same as the amount of carbonated beverage that women drink per week. Our alternative would be that the two groups are not equal to one another, because technically we would write our null and alternative hypothesis before we had a chance to peek at the data. So we run another two-group difference of means test in Megastat, only instead of using this data, as we did on the previous mini lecture, now we're going to use this data, where we're going to have a sample size of 30 men and 30 women. So we go to add-ins and we click on add-ins. And then we drag over to Megastat and we click on Megastat. We drag down to hypothesis tests, keeping in mind that we have observed two groups, men and women, and that these groups are independent of one another, as I had earlier explained. So we'll use the Compare Two Independent Groups module. Let me clear out the data there. So now it asks us for group number 1, group number 2, and so forth. So for group number 1, this time I'll work with women as my first group. So I highlight the column header as well as the 30 rows of data. For group 2 will be my men. So I highlight my column header for men and my 30 rows of data. We hypothesize zero difference between the two groups. Once again, we'll ask for our lower and upper bounds on our confidence interval. Two group alternative, so we work with not equal. We're ready now to actually run the Megastat process. So we just click on OK. And notice that our sample means are exactly the same as in the previous test. Our sample sizes have gone from 10 for each group to 30. Our standard deviations change slightly, but only slightly, not by very much. And notice what happens here is our observed p-value goes from what was previously, I think, something like 0.89. I'm sorry, 0.2479. So I'll try to get. So in the previous test with a sample size of 10 each, our observed p-value was 0.2479. In this instance, it's 0.0363. Let me just copy our critical values down here. So just to reinforce here, when your observed t-value of 2.144 is greater than your critical value of 2.101, that leads you to say I should reject the null hypothesis. Similarly, when your observed p-value is less than your critical p-value, 0.0363 is less than 0.05, that leads you to reject the null hypothesis. So consistent with what I've told you in the past, we never get conflicting evidence, whether we work with the t-value or the p-value, in deciding whether to reject or fail to reject the null hypothesis. So here, we reject the null hypothesis, and we conclude that men drink less carbonated beverages per week than women. Okay? Not surprising to us. Not surprising to us, given that our point estimates were, nearly 60 ounces per week difference for men compared to women. Women, in our samples, women drank 59 ounces more carbonated beverages per week than men. So once again, statistically, we've done our job. We ran the correct test, two-group difference of means. We correctly interpreted the p-value and the t-value. We rejected the null hypothesis. We correctly concluded that women drink more carbonated beverages per week than men. But now we go on from the statistical correctness to try to develop some managerial insight from this. And once again, that's why we can't stop at the point estimate here. We have to turn to our margin of error and confidence interval to, let me just get rid of this one. We have to look at our margin of error and our confidence interval to develop some managerial insight. So while it seems obvious to us that women drink a lot more carbonated beverages than men, and that we rejected the null hypothesis included as such, look what our confidence interval tells us. Our confidence interval tells us we're 95% confident. We're 95% confident that women drink somewhere between 4 ounces and 114 ounces more carbonated beverage per week than men. Okay, let me repeat that. Based on the data that we have in this study, we concluded that women drink more carbonated beverages than men. But from a managerial perspective, how much more carbonated beverages do they drink than men? Our confidence interval says it's somewhere between 4 ounces and 114 ounces. We're 95% confident of that. Okay? So once again, think how wide that confidence interval is. If women only drink 4 ounces more carbonated beverage per week than men, we say it's a trivial difference. But if they drink 114 more ounces of carbonated beverage per week than men, that means they drink double what men drink. So once again, we see how to do inferential statistics correctly, yet we also see that, that inferential statistics has limitations in that drawing the correct conclusion, women drink more carbonated beverages than men is no big deal. But understanding what the story is that underlies that data, that confidence interval ranges from 4 ounces to 114 ounces, is really where we can provide our client or our boss the best insight to really understand the story that underlies the data.